Hello, viewers. Good morning. Good morning, everyone. Welcome to computer science class. Gonna wait until we get up above 25 viewers before I get started. Hope you all had a nice Wednesday. Hello. I think I'm going to keep today's lesson pretty short because I assigned two things for that are due this Friday. So there are two coding assignments due on this Friday. So I'm going to try to keep it brief. Good morning. Oh wow, she's here on time. Well, only maybe like 1 minute late. We had a little staff meeting, and apparently yesterday we had a little staff meeting, and apparently some teachers are having problems like having to tell people to like get out of bed or stop laying on the couch and stuff like that. I think it's funny. I mean, isn't one of the advantages of doing school virtually is you could not get out of bed if that's what you wanted to do, right? You could lay on the couch and take your class. Yeah, it wouldn't be appropriate in an in-person school setting, but I don't see what the big deal is if it's virtual. All right. I'm going to wait maybe 1 more minute. For some more people. Please remember, if you haven't already, to submit the daily attendance. And also, the other thing I wanted to say is make sure that you guys join the remind for the class. There's the code for the remind is in the syllabus. So you click that syllabus button on Canvas and join the remind. Every now and then I have to change my office hours. So, for example, on Tuesday I changed my office hours from, I think I made it 2:30 to 3:30. So I think some people missed that message because I announced it on Remind, and some people who needed help didn't get help. So just make sure you sign up for that Remind so that I can contact you with little updates like that. All right, so I'm going to go ahead and get started. The Discord link is also on the syllabus. So Discord and Remind, the relevant links are on the syllabus. Okay, so for this first part of class, I'm going to be talking to the SL students. So if you're in HL, you can work on those two assignments, but stay on the live stream and I will call you back in about 15 or 20 minutes. If you are in SL, I'm going to go ahead and get started. We'll talk about what's going on in the live chat afterwards. Okay. So I'm going to just switch to code board. So I'm going to be using the same class that I constructed on Monday. So just to remind you, a class is a template for what we would call an object. Okay, the class has fields, which are the data that is present. Classes have constructors, and the purpose of the constructor is to set the values of the fields that the class has. Okay. You can have more than one constructor, and the compiler is going to know which one you're using. Okay, so that this is called polymorphism. You can have a different constructors, and the compiler is just going to know which one you meant to use by context. Okay, so we have two constructors. One of them, if this is called the no argument constructor on line 6, and if you call the no argument constructor, then that's going to set the x component of the vector and the y component equal to 0. Okay. Then there's a two argument constructor, which will set the x and y component equal to whatever the user inputs. Okay. Then you have methods, which are what the class does. There are some common methods that you have. You have accessor methods, which return the fields that the class has. You have mutator methods, which alter the fields. If a particular class has no mutator methods, so if a class has no mutator methods, it is called immutable. All right, and then we have just other methods. Some common methods that you will see for many different classes is to have a toString method, so that you can. So the purpose of a toString method is so you can do a println with. You can print to the terminal sort of what that particular object is, and then an equals. If it's some kind of a mathematical object or a mathematical class, it's going to probably have equals. And I made another. I made another method called get the magnitude, which does the Pythagorean theorem. All right. I'm going to make another method just to remind you guys how to write methods. So this is going to be a public method, and it's going to return actually another myVector object. So the get magnitude returned a double, but this is going to return a myVector, and I'm going to call it the add method. So, and the argument of this method is another myVector. So I'll say myVector b. So this is a method that takes in a myVector object and then returns another myVector object. Okay, so I'm going to define a double, and I'm going to call it x component. So the purpose of this method is to add the vector v to this vector. Okay, so how do you add vectors? Well, when you add vectors, you add their x components and you add their y components. Okay, so I'm going to take the x component of this particular object, and then I'm going to add to it the x component of v. All right, so how do we get the x component of v? Well, we can see we have a method that gets the x component of a vector. Okay, so you're going to put v dot get x, and that will return the x component of the vector v, and then we're going to add it to the x component of this, and we're going to set that equal to x component. Then we're going to have double y component, which is going to add to the y component of this particular object the y component of v. All right, so now I know what the x component and the y component of this, the sum of these two vectors, is, and then I'm going to create a new my vector, which is what I'm going to return. Return a new my vector with its x component equal to this this value that I calculated right here, and a y component equal to the y component that I calculated. All right, so that's going to add vectors. All right, so that's kind of a more complicated method that we than we used the other day. All right, so let's go to the main method. So I have a main method. That's kind of like the method that controls the flow of your entire program. And I'm going to show you how to instantiate an object. So remember, an object is a class is a template for what something should do and what data it should have. A specific instance of a class is called an object, okay? And so we're going to instantiate an object. So I'm going to say my vector. So that's the type of object I'm instantiating. I'm going to give it a name, v, and I'm going to say it's equal to a new my vector. And this right here is the constructor call. Okay, so if I don't put an argument in, it's going to set the x component and y component of v equal to 0. I don't want to do that, so I'll say the x component is 2.0, the y component is 3.0. All right, so this is calling the two-argument constructor of the myVector class. And then I will have a second myVector, I'll call it w, equals a new myVector. And we'll say 4.0 and 5.0. All right, so v and w are called instances of the class myVector. All right. So v and w are objects which are instances of the class myVector. Okay, so there are particular examples that follow this template that I defined last class. All right, so now I'm going to create a new myVector called z, and I want z to equal the sum of the vectors v and w, okay? So I need to use this add method that I defined here, okay? This is an add method. So I want to use that. So how do I use that method? Well, I use the dot. So for the vector v, I want to get the add method. So I'm going to dot add, and then I can see that the add method takes in a my vector. Okay, so I'm going to add to v the my vector w. Okay, and so this is going to return the sum of v and w, and it's going to set that equal to z. So what would happen if we do system.out.println of the string version of z? So I want z dot toString. Remember, we defined the toString method. What it does is it prints the vector as an ordered pair, like x comma y. So what this should do, if we look at when we add v to w, we get a vector with x component 6.0 and y component 3 plus 5 is 8.0. All right? So basically what line 10 is going to do is it's going to print to the terminal 6.0 comma 8.0. So let's just verify that that's what it does. So I'm going to compile. Boom. And I'm going to run it. And it spits out 6.0 comma 8.0. So it's exactly what we expect it to do. All right. So sort of the key idea here is you use the dot to access the methods of an object. So if you want to get the things that the object can do, then that's how you do it. Now, what I would like to do now is I would like to talk about the difference between some of these modifiers. So public and private. What does public and private mean in the context of Java? So what if I made, see how this is private? So that means that the only thing that can access x and y directly is the class itself, okay? So see how the constructor can access x directly, okay? Can access x directly. See how that just returns x. But what if I wanted to do something like z.x? z.x what it should return is the x component of the vector z, which should be 6.0, okay? But you see, if we try to access this private field, we're going to get a compile time error. So let's try it. Let's try and compile that. And it says, see how it says x has private access in my vector. Okay? So what if I wanted to make this a valid line of code? Well, I could go back to my vector class and I could change that from private to public. Okay? So if I do that, it's going to compile. All right? And then if I run it, see how so I'm directly accessing the x component from the main method. I could also do things like, what if I said z.x, and what if I increased it? by 1. All right, so that's going to increase the x by 1, so it should print out 7 because I'm adding 1 to the x component. Let's compile it, run it, prints out 7. This is really bad programming practice though, okay, because you're not encapsulating your data. Okay, we don't want to have the main function, to give the main function access to that information, okay? So you usually want to have your fields be private, okay? So the proper way to get the fields, if you want the main method to be able to access those fields, is to use accessor methods. So we have get x. All right, that is the proper way to get the information, is with accessor methods. What would happen if I made the getX method private? That would mean that this is going to give a compile time error, because in the main method I'm trying to use the getX method, but the getX method is private, so that can only be accessed within the definition of this class. So this is going to give an error. See how it says getX has private access in my vector, so I can't use the getX method from main. All right, but here's something interesting. If I go back to my vector, notice how the where's get magnitude? Get magnitude, not get magnitude, equals uses the getX method. So equals is a public method, but it uses this private method. That's okay, all right, because it's within the definition of the class. So what if I do system.out.println z.equals v? So it's going to see, is the vector z equal to the vector v? And the answer is, of course, no. So this should print out false. See, because they're not equal. Right? So that's how that works. So the objective for today's lesson is to teach you how to instantiate an object. So you instantiate an object using this sort of syntax right here. And how do you use the methods of a particular object? You use the dot to get to the methods. Okay. And then also I wanted to explain what private and public modifiers will do. Okay. So, oh, there's one more thing I wanted to say before I switch over. Let me make this public again. You can actually do multiple dot operators, one after the other. So, for example, what if I had a statement like this? v.addW. This is going to return a vector that has the components of 6, 8. That's a vector. But what if I wanted to get the x component or get the y component of that particular new vector that I created? So you can use dots one after the other. Now, what is getting x or getting the y component of this vector? What type of value is that going to return? That's going to return a double. Okay, see how get y returns a double? So it wouldn't make sense to So basically I could set this equal to a double A equals, so the y component of the sum of v and w. So if I print A, that should print out 8 to the terminal. Let's see. All right, printed out 8. Boom. So that is my lesson for the computer science SL students. So stay on this live stream, and but you can start to work on the code board assignments that you need to work on. And now I would like the HL students' attention. I'm going to check the live. Okay, nothing in the live chat. All right. So for my HL students, we are going to be talking for the next week or two, next 2 weeks, I would say, about data structures that are on the IB exam and that you should know about, okay? So this is going to be a theoretical lesson. So let me switch to my document camera. So I'm going to autofocus. All right, that didn't do much. The data structure that we're going to be talking about today is something called a stack. Okay? And a stack is an example of a data structure that implements what's called a LIFO. LIFO. So LIFO stands for last in, first out. Okay, and so that's what a stack is. It's a last in, first out structure. It's a one-dimensional last in, first out structure. Okay, so a stack is literally just what you would think of as a stack of cards. So this is a stack of 1, 2, 3, 4, 5, 6, 7, 8 objects. Okay. Stack of 8 objects. And so the stack, a stack data structure, basically has, I think it's 3 key methods. All right. The first method that a stack data structure must have is called push. Okay. So what push does is it adds another object to the stack. To the top of the stack. Okay, so if I pushed, so the push method will take an object. All right, and it will put that onto the very top of the stack. Okay, so we would have 1, 2, 3, 4, 5, 6, 7, 8. All these are distinct objects, and then we add object O to the top. Okay, so it has a push method. It puts it on. It's like you have a deck of cards and you put a card on top of the deck. All right. The other method that a stack must have is called pop. And this one returns the object on the top of the stack. Okay, so the pop method does not have any arguments. Okay, that method takes no arguments. It's just going to, so in this case, if we popped this stack, it would spit back out O. So this is how the stack would change if we push O onto the stack. But then if we pop the stack, then it's gonna, O is gonna get returned, and then we go back to having a stack of 8 things. Okay, so that's how pop works. It's like drawing a card, sort of. Okay, so the stack gets shorter by 1, and you get to keep the card. The third method, so yeah, this returns the object on the top of the stack, and it removes it from the stack. Okay. The last one, method that you kind of have to have, is called peek. Peek. And the peek method returns the object at the top of the stack. Okay, but doesn't remove it. Okay, so it's kind of like you have a deck of cards, you look at the top card, so you know what it is, but you put it back afterwards. Okay, so pop is like drawing a card. Peek is like drawing a card, looking at it, and putting it back. Push is putting a card on top of the deck. All right. So what is the only way to get to the bottom of the stack and figure out what's at the bottom? Well, if you want to get to the bottom of the stack, you would have to pop every other object that is above the bottom of the stack. Okay. So basically, and keep in mind that if you were to build up a stack, you're pushing, push, 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 push. You're building up your stack. When you call pop, only the thing at the top of the stack is going to get pulled off. So that's why it's called LIFO. The first thing that you put in to the stack is the thing at the very bottom of the stack. So it's the last thing you're going to be able to get to. Okay. There are a couple of other methods that you can have with, you can have an equals, or you can have a, another common one is, I'm drawing a blank here, is empty. So the is empty method of a stack would return a Boolean that is equal to true if there's no objects in the stack and equal to false if there is an object. So that's useful if you're trying to check, did you get to the bottom of the stack? I'm going to show you. So in the Java documentation, there is actually a class stack that they have already made. So here's the class stack. And we can see it has one constructor, which creates an empty stack. All right. And let's look at the methods. Now, by the way, this is, you can create a stack of any type of object. All right. And we can see the methods that the stack class has. It has empty. So I guess I called that is empty. It has peek. It has pop. It has push. And it looks like they also have search, but I wouldn't consider that to be essential to what a stack is. All right. So you can use the standard, sort of the standard implementation of the stack class if you want to, but for today's assignment, what you're going to do is you're going to create your own stack class. I'm calling it my stack, and it's going to be a stack of string objects. Okay, you're going to implement the push, pop, and peek methods. And you're going to implement your stack as an array list. So you're going to practice array lists if you haven't used them in a while. Let me show you the Arraylist class. So basically the field of your myStack class is going to be an array list of strings. Okay. If we look at Arraylist, it has a ton of really useful methods like add, clear, contains. It has all these different methods that you can use to manipulate the stack. Okay. These are some of the methods. So here I'm in the Java documentation for Arraylist, and I can see it's got a lot of methods for you to check out. So I would encourage you to check out those methods. All right. So that is my lesson, and I will meet you in the Zoom room to help you guys out. Okay. See you in a few.